Okay, let's finish up this section 3.1, and this is C, and this won't take too long. And we're on example 6. It says find the zeros of, and of course we're going to throw a wrench in there to make it a little bit more difficult, but once you start looking at these bigger exponents, you'll remember to use one of the symbols that we've used earlier. And I don't think, the book isn't using this method, but it's one I like to when this is an even number and I have an x squared there, which is usually going to be the case when you use this. And I remember a while back I said, all right, let's take the middle term and take the variable and make it equal to u. All right, then I can write this as x squared squared plus 4x squared minus 45. And again, the book isn't doing this, so I'm going to substitute u for x squared. And it just turned it into a simple quadratic equation there. And then I can make my terms here, and I can make this, let's see, negative 5 and what else? Plus 9 equals 0. Okay, so now I can put these back if I want to. X squared minus 5 times x squared plus 9. So I just put my x squared back in there. Alright, so making this equal to 0 and making this equal to 0. X squared equals 5, x equals plus or minus the square root of 5. And this one, x equals plus or minus 3i. Because remember, this is going to be square root of negative 9, which is square root of 9i, which this then becomes a 3. Alright, so let's move all this stuff up. And those are my zeros. Plus square root of 5, negative square root of 5, plus 3i, and negative 3i. Okay, and that's what it asks you to do. Find the zeros. So one thing to notice when you graph this, these are the only ones that are going to show up on the graph. These are imaginary numbers, so they're not going to show up on a graph. It's not going to cross at the points 3i and negative 3i, because what is 3i? It's an imaginary number. Alright, middle of page 262, I would write this down. Every polynomial function of degree n. So, like 3x to the third plus 9x squared plus 2x plus 3. There's a polynomial function that has a degree of n. There's my degree. And the n is bigger than 1. It will have at least one 0. It'll have at least one number for an answer. It'll cross the x-axis at least one number, and at most 3. Okay? Now, I want to go so far to say that if it says that it's got 3 answers, it will have 3 zeros. It may cross at 1 3 different times, so 3 may occur, or 1 may occur the same, 3 times, and so you only list it as crossing at the number 1, but it still has 3 answers. It's just they're identical answers. So anyway, right below that little box on 262, it says this is often stated as follows, which is what I just said. Every polynomial function of degree n, or in this case 3, when this number is bigger than or equal to 1, has exactly this many zeros. Alright? It says this statement is compatible with the preceding statement if one takes multiplicities into account. So again, if this answer, I got 1 3 times, it's got a multiplicity of 3, we did get 3 answers. It's just the same number. Okay? Alright, so that's it for lesson 3.1.